I will be showing you one of the easiest ways to calculate the slope, otherwise known as the gradient of a straight line. There are some prerequisites. The first of which is that the slope, otherwise known as the gradient of a straight line, is a constant. So I've got two straight lines over here. What this means is that for each of these straight lines, for example the one on the left, any point that you take on this line will give you the same gradient. In this case, the gradient might, for example, be equals to half. It is going to be a positive number. Now for the example on the right, any point on this straight line will give you the same gradient as well. And in this case, the gradient might be negative 3. And this is a negative gradient. I'll elaborate why sometimes the gradient is positive and sometimes the gradient is negative later on in the video. The second point is that you need to know how to find the difference between 2 points on a number line. So for example, to find the distance between 3 and 100, the difference between them, we know that this is going to be 97. How we get 97 units is simply take the larger number, which is 100, minus the smaller number, which is 3. 100 minus 3, you get 97. Another type of question will be the difference between a positive and a negative number. So if I have negative 4 as the smaller number and 3 as the larger number, the difference between them will be, in this case, 7. We take 3 minus negative 4, that is equivalent to 3 plus 4, which is 7. Another way you can look at it is to indicate where the number 0 is. So between negative 4 to 0, we've got a total of 4 units. Between 0 to 3, we've got a total of 3 units. That makes it a total of 7 units. The final type is the difference between two negative numbers. So again, to find the distance between them, you take the larger number, which is negative 7, subtract away negative 19. So effectively, negative 7 plus 19. We have a total of 12 units over here. So that is the second prerequisite that you need to know. Finally, you need to be able to memorize two things. And here are the two things. First is the formula. The gradient is given by rise over run. You need to memorize it is rise in the numerator and run in the denominator. Rise, as the word suggests, is to go from the bottom to the top. Okay, now next, run. We will always be running from left to right. Okay, so what you need to memorize over here is that moving from left to right is positive. Therefore, moving from right to left, which is the opposite direction, moving from right to left is going to be negative. Okay, so these are the prerequisites that we need to know in order to be able to find gradient or slope of straight lines. So the first example, I've got 2 points over here, point A and point B. Point A has the x coordinate of 1, y coordinate of 2. Point B has the x coordinate of 6 and y coordinate of 12. To find the gradient, this is where we need to call out the first thing that we have to memorize, which is the formula. Rise over run. Okay, so let's begin with the rise. So we'll always be going from the bottom to the top. Rise from the bottom, so point A is at the bottom, and we are going to go upwards. So we look at the y coordinates of A. From 2, we're going to rise up to 12, where B is. So in this case, the rise, which is the difference, is going to be 12 minus 2, which is 10. We're going to divide this by the run. Now remember, from left to right is positive. We are going to run from 1 to 6. And the run over here will be 6 minus 1, which is 5, giving us final value of gradient 2. Okay. So another way to draw the arrow will be this way. Rise up 10 units, then we run towards B, and that is a total of 5 units. So let's take a look at the second example. Again, we have the same formula, rise over run. So we start from the point at the bottom. Over here, we're going to rise up. Rise top, where the other point is. You have to be able to tell me what the difference between 6 and -5 is. So the distance between them will be 11. Divide this by the run. Running to the right is positive. So that is a total of 2 minus -3, which is 5. But this cannot be simplified further, so the gradient is 11 over 5. Moving on to example number 3. Gradient is our rise over run. We always rise from the bottom. So rise all the way up to where the other point is. You see that it is from 4. This has a value of 4. From -5 to 4. That is a total of 9 units upwards. 9 over. Now we are going to run. From here, running to the left. Now we are running to the left. Okay, so recall, when we run from right to left, it is going to be negative. So let's take a look at the distance from 3 to 0. This horizontal distance is 3 units. But remember, we need it to be, since we are running backwards, it is going to be -3. We are running to the left, we are running backwards, so it's negative. And this gives us a gradient of -3. We're going to do one last example. Gradient is our rise over run. Start from the lower point, rise all the way up. So we see that we are rising until this point. From -4 to -1, 3 units upwards. 3 units upwards, and now we are going to run. Instead of running right, we're now running left to where the other point is. Here we have a total of 3 units, but because we are running to the left, it is divided by -3. So the gradient over here is -1. So if you take a look at all 4 examples, we are able to calculate the gradient quite easily. And you should notice a pattern. When the line is sloping upwards, when we say the line is sloping upwards, we are always referring from left to right. This, looking from left to right, this is a line sloping upwards. Looking from left to right, this is a line sloping upwards. For lines sloping upwards, the gradient or the slope will be positive numbers. If we have looking from left to right again, the line is sloping downwards. Looking from left to right, the line is sloping downwards. Our gradient will be negative. So that is one quick way to check whether you might have any errors in your calculations. So that's all. I hope you are able to calculate gradients from now on.